Hi, my name is Sergey Nosov. Welcome everyone. Today we're discussing the OAuth 2.0 Client Credentials Grant. What is it? How it works? When to use it? And what alternatives exist? So, what is it? The Client Credentials Grant is an OAuth 2.0 flow used for machine-to-machine authentication. That means no user is involved, just an application or service authenticating itself to an authorization server and receiving an access token. Think of it as a backend service saying, "Here is my ID and secret. Please give me a token so I can call another service." This flow is strictly for confidential clients, apps that can securely store a secret. Examples include microservices, daemons, or CI/CD tools. The key takeaway here is that the access token you receive does not represent a user. It represents the application itself. Let's walk through how the Client Credentials Grant actually works. Step 1. The client sends a POST request to the authorization server's token endpoint. It includes its client ID, client secret, and sets the grant type to client credentials. Step 2. The authorization server authenticates the client. If the credentials are valid, it issues an access token, usually a JWT or an APOC bearer token. Step 3. The client uses this token to call the resource server or API. Step 4. The resource server checks the token and enforces authorization rules based on scopes or claims embedded in the token. Important to note, this flow does not return a refresh token. If the access token expires, the client simply requests a new one. Also, the issued token is scoped only to what the client is permitted to do. It is not impersonating a user. Because there is no user involved, refresh tokens are not needed. Only confidential clients, that is, those that can securely store secrets, should use this flow. The Client Credentials Grant is ideal in these scenarios. First, microservices, when one internal service needs to call another within a secure network. Background jobs, such as daemons, cron jobs, or batch processing apps that need API access. Automation scripts or command line tools that run without user interaction. CI/CD pipelines, such as a GitHub Action or Azure DevOps pipeline that needs to deploy or report metrics. Finally, software as a service integrations, where a third-party app calls your API based on its own service identity. In short, any environment where authentication must happen in the background without involving a user. Despite its usefulness, the Client Credentials Grant is not a one-size-fits-all solution. Do not use it when a user is involved. If you need to authenticate or authorize a user, the proper flow is the authorization code grant, especially with Pixie. If the client is public, like a spa or mobile app. Also, avoid client credentials grant for public clients, apps that run in environments where secrets cannot be secured, such as browsers or mobile apps. These apps should never use client credentials because their secrets can be easily extracted. Lastly, for devices without a user interface, like smart TVs or kiosks, use the device authorization grant, which allows users to authenticate on a separate device. The client credentials grant should only be used when there is no user context at all and when the client can securely authenticate itself. Let's talk about support for this grant in KeyCloak. KeyCloak fully supports the client credentials grant. To enable it, you create a client in KeyCloak and enable the service accounts feature. Once that's done, the client can authenticate using either a shared secret or a public-private key pair. KeyCloak will issue tokens scoped to the roles or permissions assigned to that client. These tokens can be used to call APIs protected by KeyCloak or any system that trusts KeyCloak issued tokens. This setup is great for internal service-to-service communication within a microservice architecture. While OAuth 2.0 is widely used, it is not the only secure option for service-to-service communication. Let's go over a few notable alternatives. API keys. These are static credentials passed in headers or query params. Simple, but they lack scopes, expiration, and fine-grained control. Also, rotation and revocation are manual. Mutual TLS. Both client and server authenticate each other using X509 certificates. It's extremely secure and works well in zero-trust networks or private service meshes, but managing certs is complex. SAML 2.0 assertions. Still widely used in enterprise settings, especially for federated identity. Some systems even accept SAML bearer assertions to obtain OAuth tokens. HMAC signed requests, used by cloud platforms like AWS, for example in Signature version 4. It uses a cryptographic signature in the request headers to ensure authenticity and integrity. Kerberos, more common in traditional enterprise Windows environments. It relies on a central ticket granting authority and is tightly coupled to domain infrastructure. These are all legitimate tools depending on your ecosystem and security model. To wrap up, the OAuth 2.0 Client Credentials Grant is a solid choice for back-end applications and services that need to authenticate themselves to APIs. No user involved. It's supported by platforms like KeyCloak and works well for background jobs, service accounts, and automation scripts. But it is not appropriate if you're dealing with real users or public apps. In those cases, switch to authorization code flow with Pixie or device flow. Also, don't forget, OAuth isn't your only option. Consider mutual TLS, API keys, HMAC, or SAML where appropriate. Thank you for your attention.